Yeah, Tom, actually, I'm sharing this with everybody because Tom had a very interesting point of view. He suggested to me that in the future, architects would not actually be necessary at all, but rather builders, and would sort of just have a whole kit of prefabricated parts, and that they would just hire a few designers to do some of the work. So I'm not sure I agree with that point of view. I'm sure that's not.
There's no doubt modularization is going to happen and prefabrication is going to creep in, but I think there's still going to be room for architects in there.
Well, I hope so. I hope so. And Jess, I see that you're online as well, and I see you're tearing through the courses as well. So good for you.
Thank you.
You're like in 420 now, so you must be getting towards the end, eh?
I think I took that one a little bit early, but it just fit into my schedule with all the other ones well. So yeah, making progress for sure.
Well, that's good. And I do appreciate, while we're waiting, we can sort of yak about things. We are moving ahead, albeit sometimes slowly, with our Masters of Architecture, which will be low residency. There'll be a insight kind of component of it at the start to get everybody to know each other, and then it'll be largely online. We've had pretty good feedback so far from the people that we've talked to, although some of the old guard, we do know, is still reluctant about our virtual approach to life. But in the next little while, and I see David Martin has joined us. So Jess, I know you sent me a note earlier on about support for that. I may actually ask for even more formal letters from people for support as we move forward. Certainly getting letters from students would be very, very helpful.
Yeah, I would love to do something like that.
Okay, excellent. I think we're what we've been working on. It's panning out to be a really good program and really interesting and really advanced. And there are so many opportunities for us to work globally with other people that it almost seems silly if we don't. So we are working forward with that. And because it looks like it's going to be a small group this evening, although you never know, people are always slow to join these things. I'll just shout out to David Martin, who I see is online as well.
Hi, everybody. Good evening.
Hey, David.
Hey, good evening.
I think this is going to be, well, Henry, we can wait for just a few more minutes, I think, as well. But this does look like this is going to be a great talk. Hammad gave us a brief synopsis of this when we met with him in Calgary. And we didn't even know, actually, that he was one of our students at the time. But when we saw what he was talking about, I thought we should share this with everybody because it's really, really good. And over the next little while, we'll be doing more of these lectures. I know, David, we're going to see something from Brendan about his portfolio. And I know that InDesign was a key component of his portfolio. And I know you mentioned, and two other people mentioned as well, that you have some experience with InDesign. And that would be great to share as well. So once we get these first two out of the way, we would encourage other people to actually share things with us. And we do provide a small honorarium for these things because we know it does take a certain amount of work to put together a presentation. So we would encourage you, if you have something that you'd like to share with the other students, let's do it. My hope is as well to start to reach out. We're going to test this idea with a sort of a student-enabled kind of lecture series, but then I'd like to also branch out and ask some different people, different kinds of architects and people from around the world to talk to us about what they do. And if you have suggestions for that, let Henry and I know. It's also a good time, and you can tell I am filling in the space here as we wait to see if anybody else is going to join us. If you have questions about the program, just shout them out, because as I say, it looks like there's just a small group of us tonight, and that's okay. It's probably not a bad thing to test with just a small group, and we'll see how the whole thing works.
Well, one thing is that, Hammad, we are recording this session. So I'm hoping to share the recording with the students later on our Padlet page where students log on to look for information.
Yeah, no, not a problem. Sounds good.
Thanks.
And while we're waiting, I'm always happy to talk, as you can tell. But while we're waiting, I'll share with you that Henry and I have been sort of exploring some really interesting ideas that are happening around the world, and even trying to knit them together. Just the other day, we met with somebody online. Now, this person, she was teaching at a university in Ghana. She was at a conference in Casablanca. We connected with her via Zoom, and it was really like she was just around the corner. She wants to try and create a new university in Uganda. It's pretty ambitious. We said we would help her. She doesn't really have funding, but she has a sort of a dedicated point of view about the whole thing. And so we're hoping that if we can in any way, shape, or form, we would help her. And then the students at Dalhousie in the architecture program, they've started a new kind of movement because they're concerned about the curriculum not really addressing anything to do with climate change. So, Henry, are we meeting with them tomorrow?
Yes, we are meeting with them at 4 o'clock tomorrow. And if any students would be interested in this project, we would welcome them to participate. I think even that's probably even better if any of our students would be interested to talk to them, because they are also a student group, and they're trying to propose a shift in architectural education and even in the profession to more of a regenerative design.
Yeah, and I think that's critically important. Our curriculum, even ours, is getting a little rusty, if you want to know the truth. So I'm hoping that we can start to address things as we move through and create the courses for the masters as well. But the thing about, and you're absolutely right, Henry, there's a point at which the faculty has to get out of the way so that the students could talk to each other. What we'll probably offer them, which is the same as we offer to the person who wants to create the Ugandan university, is the use of our resources and our facilities such as Zoom in order to connect people around the world. And if there's any students at Athabasca, such as the people who are online, who would like to be the representative to this group, it's called Supernatural, and it has a website, supernatural.com. I think at this point in time, that would be the ideal way to move forward. And so just, again, drop Henry or I a line if that might be of interest to you. And I suspect, Henry, what we might want to do is we probably could get started, and people may join us as we go along. But we, as you probably have guessed, we like to do experiments at the Center for Architecture, and this is just another one of them. It seems like we're not really exploiting the full capabilities of our Zoom system, which is pretty robust. I mean, this is some of the best sound I've heard, and we don't have a lot of interference. So this is actually working out quite well. But I wanted to just say a note of thanks to Henry for getting all of this organized, because we would like to do more of these events to create a better sense of community. And Henry has done all the heavy lifting on this one. So I'm really just gonna turn it over to him, and I'm gonna go on mute for a little bit.
Okay. Thanks a lot for the welcome message, Douglas. So today I would like to thank Hammad Chaudhry, who will be our speaker today, for giving a lecture to us for our inaugural virtual lecture series at Athabasca University. So the topic of the presentation is on virtual design construction, BIM, and digital workflows. And just to introduce you, Mr. Hammad Chaudhry, quickly, his role is Director of Western Canada for virtual design construction at EllisDon Construction. So thank you very much for doing this, Hammad, and I will pass the mic to you and to start the presentation.
Perfect. Thank you. Thanks, Douglas, and thank you, Henry. I'm very excited to do this. So yeah, my name is Hammad Chaudhry, and I look after VDC, or Virtual Design and Construction. Essentially what that entails is everything to do with 3D modeling, 3D scanning, and the use of essentially, construction technology and design technology. So EllisDon's a very large company. We're the second largest general contractor in Canada, and we have the largest BIM team. So we have over 100 folks almost now that work coast to coast within one facet or another doing virtual design and construction stuff. So that's quite an extensive team compared to your typical general contractor. And the other thing too, I want to point out, as Henry mentioned, I'm the virtual design and construction director for Western Canada. That's just one of several pieces of the organization that we have. So we have folks that are architects, engineers, actual foremen who became, different business development folks and stuff like that, and everything in between. So we've become a very diverse company to serve sort of that marketplace that's evolved. And so before we get a little bit deeper, I just want to point something out, something that Malcolm Forbes said, the best vision is insight, because I think we need to take a little bit of an overview of the industry and sort of some of the trends behind it to understand why, virtual design and construction is going to be very pivotal when you look at architecture or engineering and construction going forward. So the first thing is to point out that across the globe, roughly 7% of the working age population is in the industry of AEC. And that means that, this is a consequence of it making it the largest sectors in the economy, one of them. We have almost just in construction alone, about $10 trillion spent every year. And if you look at the trends that we're looking at from different sources, this, chart here is from McKinsey. It's showing that the amount of money being spent on these mega projects is going to be increasing significantly. So just looking in our own lives, think about, the Calgary or Edmonton, Toronto, Vancouver airports, and how, within the past 10, 20 years, they've definitely gone through some significant project overhauls. If you look at across the world in terms of energy projects, now you're looking at Tesla with the Gigafactory. These trends are very apparent in front of our own eyes, and they're not slowing down. But one of the things that really is stark and causes a little bit of concern for folks is the fact that the majority of projects are, over their original value or the budget, and the fact that they're behind their original schedule. So that means that not only are we, going to be using more money than we anticipated to build these projects, we're also not going to be able to deliver a lot of these on time. So what's a way that we can, reduce some of this risk? Well, looking at some of the more advanced societies around the world, we realize that even they're facing these problems. So if you look in Germany, at the Berlin airport, this project was about 1.2 billion euros over budget, which is about 6 times what they originally thought. And not only was it really behind schedule, but it was ridiculously behind schedule. So originally they thought it was going to open up in 2011, and they weren't able to open up until even recently now. And if we shift gears and we look at sort of Apple as, the tech guru, even though they're the most advanced company in the world, some would argue their project was more than $2 billion over budget and almost 2 years behind schedule as well. Another key piece of information, which is really driving construction technology and design technology right now, is the productivity gap. So essentially at a high level, what this means is if you look at construction compared to any other traditional industry, especially manufacturing, there's almost a 2-time gap between how every $1,000 per worker gives you a return on your output. So what we're starting to see is a shift within the AEC industry. And a really good example of that is looking at Dell, in my opinion, from the computer industry. So back when Dell started, they were essentially just putting pieces together from other firms' parts. What they realized they had to do to stay competitive was create vertical integration within the supply chain. So they made strategic partnerships, and Michael Dell called this a tightly coordinated supply chain. And what this allowed them to do was not spend capital to buy up companies necessarily, but make strategic partnerships with other companies in his supply chain so they get better, pricing and could compete. Now, this is similar to what we're seeing with large projects within our industry. So think about your large hospitals or, highway projects, or even, your public library projects. They're typically, public procurement methods of a design build or a P3, where the architect, the contractor, the subcontractors, and the owner are all creating these kind of relationships. But one of the key differences for, architecture especially, is the fact that we don't have two buildings that look the same. Even if it's a hospital or a high-rise tower or an airport control tower, all of these are going to be unique time in and time out. So a unique product versus something that's very repeatable, key difference. Another issue we see is that there's a lot of fierce competition within the industry. So if you look at the US or, in Europe or North America, generally speaking, there's hundreds, if not thousands, of different contractors that are ready to build these kind of projects. Whereas if you look at it on the tech side of things, you want to go get a new smartphone or a vehicle, there's only dozens of options at a maximum if you look at manufacturers, right, or different companies like that. The other issue too is the profits are very thin. So that makes it hard for construction companies and architectural companies to make a lot of heavy R&D investment, right? And therefore that means that the thinner our margins, the less R&D that's likely. And if you look at the cyclical nature of construction, it's very clear right now. So if we look across Canada and Toronto, we're experiencing significant growth. The number of projects in that realm for us as EllisDon, we've almost had to turn projects down. Or if you look at in Calgary, the volume has slowed down significantly. And so that is very, very reflective of why there's a lot of different contract types in the industry. So we work across, anything from a CM or construction management contract all the way down to a P3, and each contract is trying to shift risk, right? Now, another key piece of information is the fact that according to some estimates, so this is McKinsey again, and there's various estimates you could take a look at, but we have a lot of folks that are estimating that there's about $1.5 to $2 trillion being left on the table from a loss of productivity. So that's where VDC is coming in. So what we're trying to do is focus on each area of a project's life, pre-construction, construction, and post-construction, and really implement a process that allows us to leverage construction technology. So I'm not going to go through this process in detail, but I wanted to explain that as every project evolves, whether you're on the design team or you're with, an owner or you're working for a general contractor, so on and so forth, there's a very, stipulated process that you could follow to ensure success on your projects. And this is becoming more and more clear as a mandate. So right now we're working on dozens of projects. Brookfield Place, we wrapped that up recently, and there's some pretty heavy requirements on that. So $500 million project, where we use 3D modeling with the trades and the design team, some 3D scanning to create an as-built model at the end of it. 400 West Georgia, this is in Vancouver. This is about a $140 million project. And we're working on this right now. Again, we've done a lot of cool things on this project, leveraging 3D modeling, even 3D printing models and stuff like that. The Well is another $500 million project right now we're working on in Toronto, high-rise, very architecturally significant, and we've gotten to the level of doing 4D, which is marrying 3D model to the schedule. And then lastly, at a high level is YVR. So this is a commercial project with a lot of infrastructure guts that is part of a very unique scope of work, right? So we're not only do we have to use 3D models to get this project done, we have to deliver 4D deliverables to the client, and we're 3D scanning, and there's also a lot of data as built requirements. So this is the full gamut of using construction technology, all while making sure that the airport stays operational. So it's quite a heavy project. And you know what? We use it on big projects, small projects, all across the board. We work with a lot of smaller architectural firms, some really big firms, and at the end of the day, the tools make it a lot easier for us to pull off a smooth execution of these projects. So if you look at the AGO, Ontario, Art Gallery, it's a very significant project, architecturally speaking. And once you go inside, you see this beautiful, work of art, literally, which is the facade. And without these sort of 3D driven fabrication technologies, we would not have been able to pull this off within the time frame that you needed to get it done. And same thing on the back of this building. If you look at that staircase there, it's just, again, another piece of art. But how are you going to coordinate that without 3D tools and technologies? So what we had to do is break out this into different scopes of work and packages. And once different elements arrived on site, we used a 3D scanner to capture this information so that the next scope of work or contractor could build their information to coordinate with that. If you look at, the Edmonton Control Tower, that's another, really good example of how technology not only made it possible to design this information, but also how it made it possible for us to fabricate and install. So essentially, to put it at a high level, we're looking at creating more tangible information and de-risking this for everybody in the project. So typically you'd look at 2D drawings like this, sections and schedules. What we found is that if we have 3D tools and technologies, we can put together information that very accurately shows what's going on.
Oops, seems like we lost.
Did we lose Hammad? I'm just seeing a kind of a lonely little white telephone handset. You're still there though, Henry, right?
I'm still here. Hammad, are you still there?
Looks like he might have. Do you want to send him a chat, Henry, to see if we can get him back on?
Yep.
That serves me right for touting the reliability of Zoom, isn't it? I should have known that if I said that, we'd have something like this.
You jinxed it.
Absolutely.
Okay, let me just send him a quick message.
Okay.
Oh, he's back. He's back.
Back. Wonderful.
Hello?
Yep. We seem to have
Hey
missed
guys, can you hear me now?
second there.
Perfect. Hey, sorry about that. I don't know what happened there.
It's all good.
All right. Can you see my screen?
Yes.
All right. So sorry about that, everyone. Picking up where we left off here. So essentially what I was trying to get at is using these tools of 3D technology, not only does it make it easier for people to visualize what's going on, but we can catch a lot of these issues that typically fall between the cracks on, 2D drawing production. And so we're going to go through some examples and give you a little bit of an overview of what we mean. So at the beginning stages of a project, an architectural firm and a client may be working together and they have an idea of the project they want to build, but they don't know who's going to build this project. So what they do often is come out in the form of an RFP or request for proposal and ask different construction teams to explain how are you going to put our building together. And so what we have been focusing on at EllisDon is creating tangible little videos that marry the construction schedule to the actual model to explain to our clients how we're going to be executing our portion of the work. So it can include things like your trucks, where the material is going to come in, your cranes, if we have any lane shutdowns, And then it also goes into the detail of showing the structure and your, facade, your curtain wall, and so on and so forth. So I'm just going to speed this video up a bit so you guys can take a look. And on this 400 West Georgia project, one of the things that really makes it a challenge is that each of these bays that you see, there are 4 floors each, and they're all offset and skewed. So you don't really get a straight path throughout the tower or the building. So placement of cranes or your material hoists, or even logistics of getting your typical services like your elevator and stuff like that up, really do play a lot more of a challenge than you would anticipate, even though it looks like it's just a bunch of boxes stacked on top of each other. So that sequence is very important to explain to the owner, but that's a little bit high level. On the same project, we were able to use 4D modeling to take it a little bit more detailed. So we had to explain in detail to ensure that we stayed on track for a construction schedule. How are we going to use, each of these model elements to replicate our installation sequence for steel? So this is literally down to your nut and bolt level granularity. The other reason why this technology is becoming a lot more important for not only us as EllisDon, but for our design partners is it's becoming a lot more complex in terms of the geometries and the needs and the tastes of the clients in the industry. So in order to pull this off, we need computers that can do things like parametric modeling and leveraging repetition. But at the same time, we're losing that ability to have insight into very, very detailed, coordinated building systems. Because even though the building itself is the main goal of any project, in order for it to operate successfully, you need mechanical and electrical systems. Think about that as your lungs and sort of your heart and your eyes and all that kind of stuff in your body. These are the things that really make the building valuable and sustainable long term. And by using these 3D tools, you're able to not only dig into those, but even unconventional areas such as concrete. So that same project there, Manulife downtown in Calgary, we used that model and pushed it down to the folks in the field so that we could get prefabricated concrete formwork. And then, you can see that those are the concrete trucks there on the bottom left. And then if you look at the right side there, that's all the prefabricated elements that were derived from a model. So if you think about it at a high scale, like, you're an architect who's working on this building, who would have thought that your model would have been repurposed downstream to provide these formwork pieces for these guys with hammers and nails, right? So, the technology really has some deep and profound impacts. Another really good example of that is shop drawing reviews. On one of our projects, Brookfield Place in Calgary, we had these huge monster transfer girders, and essentially they transferred the load of the tower to the ground below and into the parkade. And so to order these, monster girders, the steel had to be ordered directly from Germany, and there's a procurement tax. So when you're ordering something this big, it comes on a boat. It's coming from the port, so you have unknown factors like customs and stuff like that. But shop drawing reviews was not something that we could waste time on. So we implemented a 3D shop drawing review process where the engineer, our fabricator, the architect, and the owner, we were all in a 3D environment getting updates real time. So think about it like MSN Messenger or ICQ back in the day, but for construction projects, right? And essentially that saved us a lot of time. We only sent one submission through at the end of the day, which is quite remarkable. Another really cool project that we used, various technologies on was the Park Casino in Vancouver. So this is right by BC Place. And there's a lot of, variables on this project. So, the hotel requirements kept changing. There's 2 different hotels. The requirements for the actual casino were a little bit changing at the time. So every design iteration, we had different amounts of concrete and steel and curtain wall and you name it. So using technology allowed us to simplify and color code information to this level where red meant, hey, this is no longer there. Green meant, hey, this is brand new. And, you know, other colors could signal that, hey, maybe only a little bit of this has changed. And we were really able to bring that kind of a technology and approach to a lot of our different projects. So not each project is the same. So we don't use the same approach when it comes to technology. So on the left side of the screen, this is a hospital we're working on right now in Kamloops, where we're using the model to do concrete drawings. So we know how much concrete we're pouring, how much formwork we need, and so on and so forth. The graph on the right, we're using this for a project in Ottawa where we're tracking the quantities per design iteration. So when you're looking at your design development, you go into you know, your construction documentation phase. How much are elements changing in terms of weight, quantity, and all these metrics? And then on the bottom right is just this tracking of some of this information. And one of the things that really is key is that everybody participates in a process like this. You know, everybody could be pulling their weight, but I often say we're only as strong as the, you know, weakest chain link that we have in this process. So if that means that the architect's not working or one of the subcontractors, the efforts of everybody is broken. So in our projects, we have, you know, the owner, the architect, the designers, construction administrators, the subcontractors, all sitting there calling in, working together. It's a very good, you know, reflection actually of what Douglas and Henry are doing with these virtual lectures. It's the same kind of idea. But what that looks like on the model land or on the 3D side of things is you end up with these really highly detailed models which are being brought together so we can run, you know, construction coordination challenges. So, you know, does this duct fit through this wall and stuff like this? But we can get even more granular as in, hey, you know, we need X amount of clearance from our door swings, or hey, we need to have this much clearance for different equipment pieces, and all that kind of stuff. So the model is really a replication of what's going to be built on site. So we want to treat that with, you know, that same kind of value that you would building it out in the real world. And so that's why it's really critical to partner with folks to understand the value of this technology, because downstream the effects are just too much to measure. So here's another example of a project where, because we had a really robust model, we were able to run exercises which saved the owner and ultimately the project hundreds of thousands of dollars, because a lane closure in the city of Edmonton is not a cheap thing to do. So we were able to optimize where the crane is going to be placed. After doing that, we were able to render an image that you see on the top left there, which was then distributed to the owner group and everyone like that in a way that they could distill the information. So we still produce those 2D drawings that are very information heavy, but the way that we proposed it to the client really let them, you know, present it to their stakeholders and ultimately helped us move forward with a solution that saved us a lot of time and money too. One of the ways that we're really leveraging this is using platforms like Revitso or BIM track, where you're able to track a lot of this information regardless of the platform. So recently we had to do a helicopter review where there's very stringent requirements for the health authority, and one of the consultants only used a Macintosh. So luckily, because we're using tools like Revitso, we were able to get their team on board, the client on board, and a bunch of folks on site using iPads, and it didn't make a difference because of that level of technology integration. And what we're able to do is track a lot more than just simple clashes of, hey, this duct isn't hitting there. It's also using this to create transparency between, you know, design teams. And ultimately, we're able to pull a lot of these metrics, which is what really is driving decisions nowadays, is data, right? So we can, for example, filter down by level if you wanted to, or by a different discipline of how many issues we have or how many sort of different tickets we may have open and the progression of us solving them. So that way, within 30 seconds, we can tell if the project is progressing or not. And ultimately, this means that we know that we can build off of it. So going out on site with your iPad, you can pull up the model really quickly compared to where you're looking at in the progress to make sure everything's going okay. If you go to most of our site trailers now, you'll have these TVs, you'll have the models and the drawings paired And you'll increasingly see more and more of the folks, the trades and the owners using the model over the drawings. And then, the data, again, going back to that, this is an example of how we're tracking it. So anybody in the project can log into this web-based viewer, and with simple color coding, green means it's been installed, red means it's not there yet, and we can compare that to the actual site photo, right? So I'm just going to go back and forth again because I think it's really cool, but we're using, very simple model-based communication to represent what's happening in the physical world. And these kind of processes allow us to use technology to a level where we can actually fabricate off-site. So if you look at these drawings here, what they're actually illustrating is prefabricated spools for systems in a high-rise tower. And this is just like Lego. So the folks come on site and they install this information just like Lego. So they can be in the form of prefabricated multi-trade racks. It could be bathroom pods. It could be mechanical skids for systems. It could even be your, facade architectural system. And a lot of the benefits for this is if you do it right financially, there's some incentives at times. There's a lot of flexibility for you to make decisions and change the design. You can control the quality a lot more than trying to build it on site with, the weather conditions that we see typically out here. And you can allow for what's known as just-in-time delivery, right? And at the end of the day, safety metrics go up as well. There's huge correlation of safety being a lot higher in prefabrication elements. And here's another example from a project that we just wrapped up where we used this approach. We used the design model. We used it with our contractors to get the fabrication details out. And at the end of the day, it was installed like that. And yeah, so it's not the future anymore. This is sort of what's happening in the industry. And so what I want to show you is a little bit more adding, logistics, adding schedule. You get 4D modeling. We looked at that video at 400 West Georgia. But what if we add financial information to that and resource tracking? So then what you get is something called 5D modeling. And this is something that's going to be more and more important as productivity tracking gets tracked. So we can look at not only what we were trying to build plan-wise, but what we're actually building, look at that with how much money we've spent compared to what was forecasted, and how many people we have on site physically working. And this is the granularity that, the technology is going to allow us to get to. So this is not commonplace whatsoever yet. This is still a little bit out there on the fringes, but the fact that, we do have clients that are looking at this means that the industry is shifting to that level. Another really great aspect is using technologies to capture what's around us, right? So we can design for these, repurposing jobs or for future tenant work and stuff like that. So what you're looking at right now is from the YYC International Airport, where there's a lot of in-slab feeding. And these little pipes carry fluid that, allow the slab to get warmed up, ultimately providing a nice, warm, comfortable environment for the travelers that come through. But they needed to know where they were for future use so that we could put kiosks in without damaging the line. This is a mechanical room as well for, another project where they needed to expand their building and they had to bring in mechanical systems to tie into that. So by going out there, 3D scanning all of it, and then creating a 3D model, giving that back to the design team, you're really able to reduce a lot of risk. And a lot of the design firms that we're working with now, some of the more cutting edge ones, if you will, they're actually able to do a lot of these processes in-house as well. And so for us, that's an interesting shift, is that a lot of these architectural firms that want to use BIM and technology are starting to use scanning as a part of their workflow too. So here what I'm explaining is our overall, how do we go from the field to your final product? So we use a laser scanner. There's a variety out there. If you have any questions ever in the future, feel free to reach out. Once you scan your information, you register it so it's all aligned and works with your model. Then we can bring it into Revit, do our scan to BIM modeling. We can do some really high level QA/QC on it, and then ultimately 3D coordination, which allows us to do some really cool things. So on this project, it's similar to that other steel I was showing you, where we have multiple scopes of work and we need the trades to be able to put this together within very tight millimeter tolerances. This is another output that we can create, which gives you very quickly how flat is the floor across the building, right? So imagine you own a shopping mall and you've got concrete poured across this and you need to put tile on it. There's a lot of deviation. The cost to level the floor just to put the tile down can be significant, right? So these are the kind of things that people don't typically think of, but you can capture using a lot of this data and inform design and ultimately what's going on with the project. Here's an example of a mechanical room that we captured for a YVR and turned it into a 3D model and gave that over to the design team so that they could continue on the expansion of that project. And now, again, talking about that 3D model earlier, here's some evidence of it. So 400 West Georgia is the picture on the bottom and on the right. And then if you look at the picture on the top left, that's University of Victoria. And essentially with these projects, what we've started to do is print these models out so that people can use their hands to discuss these issues. And the model actually comes apart. We print out site plans that's very indicative, you know, either like a Google Maps or something similar. And you plot the building down and you show them how much room certain things are going to take, your cranes and stuff like that. It really allows not only the design team and the owner, but even for some of our internal folks to visualize it in a way that no amount of 3D drawings or 3D models could ever convey. And another really neat technology that's just shot up over the past couple of years is 360 photography, where we're seeing, you know, people are able to literally record videos in 360, walk a project and dump that information as an archive back onto a system. And so we've been experimenting with this. We have a lot of projects now that just use 360 photography to track progress. So, you know, where your piping is and you put your insulation and your drywall, instead of taking, you know, 10 pictures of one room, you only have to take one. You can come back and look at it. Very cool. And now we're starting to see integration of 360 photography back to your model, so you can compare your design to what's being installed. And one of the more, you know, video game aspects of, if you will, virtual design and construction is the VR side of things. So we're starting to see a lot more traction in the industry with this. So not only are clients starting to ask for it on the larger projects, but we're starting to see that even some of the talent that you're trying to recruit now at companies want to see these tools to be used within day-to-day work or some sort of a process in the company. So just recently we had a meeting with a client in Vancouver, and they own about 3-4 high-rises, a very big complex. And as part of their RFP, they wanted us to prove that we knew how to use construction and design technologies. And so what we ended up doing was scanning their project, creating a model, a 3D model, and then putting it in a VR environment just like this one here, and putting the client into it and their team so that they could literally fly through, look at the point cloud, and look at their 3D model, and really get a feel for what kind of technology is available out there. And, you know, lastly, wrapping up the project's done, you're turning it over. So what typically architects and contractors have to do is provide these binders and manuals to the owner and the operation team. So if you look at this picture, there's, you know, dozens of binders that are super thick. And anytime, you know, we come back to a project, this is what that room looks like at the end of it, right? So everything's sort of chaos and not organized. So what we've been really focusing on is how do we get that into a digital realm, right? So we leave the client with just a digital file that encompasses all of that. So this is an example of exactly that. We're able to create an as-built model that was embedded with all that data. So think about your shop drawings, your operator manuals, your warranty certificates, your installation dates, all of that kind of information being built into the model. Instead of looking through dozens of binders and all of that, you can open up the model, sort of fly to the area that you're curious about, click on that object, and investigate it. And, you know, this is becoming a lot more intelligent as well now, and that's what we've been focusing as well, is why do we need to stop at that? Why not take this to the IoT or the smart buildings realm And so at EllisDon, we have a group that also focuses on taking all of these sort of backbones of your system and making them smart. So think about, you know, the high-rise towers that you folks see. Imagine in the next 5 to 10 years, you're going to be able to do the same thing that you can at home. So you can be like, you know, hey Google, turn the, you know, temperature down, or hey Google, turn the lights off. Imagine that being done at a large scale throughout the portfolio of these corporations. So taking systems that are all chaotic, like you see here, and sort of tied into a single building dashboard, and are really intelligent, and give the owner and the users an experience that is refined and a lot more, you know, responsible for giving these optimized results, right? So imagine what you can do if you know exactly how much power your buildings utilize them throughout the day, throughout the year, and now you need to replicate and build another project somewhere, and so on and so forth. Or if you know, some of your tenants are complaining, hey, it's too dark or it's too cold, you can look at these graphs and the heating from the sun to make these kind of adjustments. Very smart. And we've been able to pull this off on you know, half a dozen projects from coast to coast. Manulife, Brookfield Place, we're working in different facets there. And then even if you go out onto the East Coast, we have several projects, you know, in Halifax, America's head office. Very cool if you get a chance to check that out. Really cool things that we're seeing with prefabrication, again, which is really driven by design and construction integration, is rapid growth of buildings. So what you're seeing on the left is about 10 weeks before what you see on the right. And so they were able to put the structure together. So that includes all of your prefab elements, your bathroom, your facade, your concrete, within 10 weeks to get up to that. And typically that would take you over 6 months on a traditional build method, right? We're also seeing a shift of technology being used to bring more integration between GIS or sort of that realm of things and BIM or VDC. So the use of drones and laser scanning and 3D modeling to get more accurate representation. And of course, this is on large scale projects, but we're also seeing it on smaller projects where the drone usage has become so easy. The app does most of the work. So, you know, you still need to get your certification and all that kind of stuff to make sure everything's good with Transport Canada, but the risk of having the pilot physically flying now, a lot of that's being offloaded by the technology, and that allows us to do lots of cool things. So this could be before you build your project, you could go fly and get an accurate understanding of the grading and all that kind of stuff. It could be during the progress, so you know how much dirt's been moved and all that kind of thing. Or it could also be used as, you know, site update photos. But the real value is when we bring 3D models of what we're planning to build with the existing conditions and the drone data and the laser scanning together. Ultimately, you're meshing the different technologies, right? And what we want to do is focus on the process. So a lot of confusion exists about BIM being a technology. Quite frankly, it's a socio-technological process, meaning there's the people, there's the technology, and there's the process. And when you marry all these together is when you actually get the tangible benefits, right? So I don't want to leave anybody confused here tonight thinking that, hey, we're using 3D models, we're doing a BIM approach. You know, a proper BIM approach from an academic standpoint is a process. So, and then looking towards the future, right? What is on the horizon? So machine learning is something that's really, really becoming well invested in, especially right now in construction technology. So we're building a project out in Manitoba, Kiat, and that's a huge dam. And so imagine how many tours these big rigs do day in, day out over the past 5 years. Well, with machine learning, not only are we able to get, you know, automated, you know, robots to drive these things, we can optimize our paths as well. So there's a lot more efficiency that you can gain. And the other thing is, it's hard to find people that have the skill or the training to drive these things. So you're addressing a labor shortage as well. Another really cool thing that we're starting to see is, you know, either using robots to replace humans or to aid humans. So in this example, an individual will take about 3 to 4 times as long as this robot will, but the robot can't really move itself. So in this kind of a case study, right, it makes sense to have an individual with a robot versus having even 2 additional people for that labor productivity gain. Or in other scenarios, we're seeing that people are developing these wearables that are helping people lift heavy equipment and get their jobs done while reducing that strain or that physical feeling that you get, right? So trying to get more people into the construction industry that typically you wouldn't see by using technology to reduce a lot of that physical barrier. And of course, using the data, right? So how do you integrate your data? How do you read it? How does it inform your decisions or your design? And a lot of times, you know, when I speak to architects or prospective architects, they sort of roll their eyes when I talk about design and data analytics. But that's why I put this video in here. It's a very real threat, especially for architects. And you know what? Douglas really alluded to this. So this is an example from different governments. This is the US government, but they're looking at using data from past projects and computer systems to really create designs. So again, I'm going to play that one more time, but if you can program all your information, it can come in and create a floor plan how you feel like you want it, run optimizations, and then it'll auto-populate your Revit model, which will create working drawings and so on and so forth, and all your schedules. You know, is there a need for architects? No, again, this isn't going to happen overnight, and this isn't going to happen at a large scale, but what we're trying to prove here is that construction technology, design technology, and technology in general is having an impact, and there's a way to leverage it that really does provide a competitive edge for companies right now. And because especially I think folks are becoming architects right now, you have an advantage to embrace this technology, because that is something that's really hard to find. It's folks that are not only well-versed with design and sort of that background, but also are able to push the technology. So before we wrap up, I want to, you know, leave a quote here so you guys can sort of reflect. So this is from Patricia Schumann. She's a librarian, I think back in the 50s. So this is a really old quote, but it's never been more applicable, I feel like, than now. So essentially what she was saying is, we're not experiencing, you know, an explosion of information. It's actually data. We're experiencing an explosion of data. And just having data on its own is not going to help you. You need to be able to access that, right? So you need to know how to use that data in a really good way. And what really sticks with me is we're experiencing access to access, right? So look at the tools that we have available. How can they be used downstream in the full cradle of the project? How can they help you on the design side, but how can they also help overall the entire life cycle of the project, right? So yeah, thank you. And if you guys have any questions, feel free to let me know.
Thanks a lot, Hammad. I think the presentation was very enlightening. And since we're not a very big group, maybe I'll just open it up as an open discussion if anyone has any comments or questions following the presentation.
It's just David. I have actually kind of a more of a simple question for you, just on how the 3D scanning works and gets incorporated into the models, especially the Revit models.
Yeah, so the way that it works is we use a variety of laser scanners, and you know, depending on which company you use, they all have a little bit of a different process. But generally, you use your scanner, you capture the data point, you bring that point cloud information back, and you register it, and then you can export that point cloud as a reference file to be used, like a recap file or something like that, into Revit. And then once you're in a Revit environment, you can sort of start modeling over top of that point cloud. And so once you do that, you can get rid of the point cloud, and now you have clean design sort of, or a Revit file that is representing that space. So it is a lot of work to do it accurately. You know, so some people might go, and if you cut corners, it's not going to be an accurate representation. And there are, you know, some automation tools out there for that. But at this moment, you still need to spend a little bit of time doing QA/QC and modeling it and really paying attention.
Cool, thank you. My final question was a little bit more esoteric, I guess. It had to do with the transition from even going from machine learning to more AI in design stuff. I didn't know if you had any insights on that.
Yeah, you know, not as much as I wish I had. I think it's a very fascinating side of the industry right now. With machine learning, there's a lot of money right now being dumped into these kind of startups that we're starting to see trickle into the construction and design industry. So one example recently is a Canadian company, and what they're trying to do, or sorry, they're an American company, and what they're trying to do is get a bunch of contractors and design firms on board, and they want access to all of your project data. And they're going to go through, dig through it, and essentially they want to set up, you know, these progress monitoring on your new jobs. And they're going to tell you, hey, based on, you know, our machines learning, your project is going to be doing well or bad or so on and so forth. So, you know, 5 years ago, that kind of a company didn't really exist in our realm. And now that company's out there trying to sign up different companies to become their clients. And we've also seen, you know, like venture capital firms like Brick and Mortar, which is an offshoot of one of Bechtel's, I think, family members, investing in a lot of these construction technology and design technology firms. And if you look at their portfolio, it's like 90% design technology and construction tech firms. And now the newest trend is literally on machine learning and AI. So I think within the next couple of years, we'll see a lot more, David. In terms of day-to-day application, it's a little bit too early.
Yeah, agreed. Thank you very much.
My pleasure. Anything from you, Jess?
I think the whole, maybe less a question and more just sort of my thoughts on the whole machine learning AI thing. I think we've seen a lot about how this deep learning thing, it's only as good and as unbiased as the people who make it. And, you know, often there's a lot of sort of inherent bias that goes into that. Do you think that like the architecture industry and the construction industry in particular is sort of ready to do that at such a big scale, or do you think that might have sort of interesting implications?
Yeah, absolutely. That's a very good point. And again, like I don't have enough insight to make an educated comment on that either. But it is very, very, you know, it raises a lot of eyebrows, that's for sure, because there's already been a lot of discussions, I think, in the backgrounds about, hey, if this technology does get too far, when is it too far? Because already with, you know, just 3D models, you have access to accurate information on buildings. And if you look at a wide scale, that could be very classified information in one sense or another. But now if you have machine learning and AI, and like you're saying, if there's biases and all this kind of stuff in place, the implications are too hard for us to even quantify, I think, right now.
Yeah, it's really interesting for sure.
Yes, Hammad, I wanted to thank you very much. It was a very clear and articulate presentation, and you covered a lot of ground, but you covered it very clearly. So thank you very much for that. I want everybody in the Center for Architecture to see this presentation, which is why it's great that it's going to go online. And Henry, just before I forget, if we could maybe capture a screenshot or two of some of the things that are going on, that would be wonderful as well. But it does raise a huge question for all of us about how the profession of architecture has to evolve to deal with these new technologies. But as a secondary, as you know, a secondary issue of that, how does architectural education have to evolve in order to prepare people for this, what is essentially a radically different world of construction? And in posting that, asking that question, I'm putting that out to both to Hammad and to Jess and to David and to Henry. If you have any thoughts on that, I'd be very interested.
Yeah, that's a $1 million question there, I think.
I mean, but it is one we grapple with because, as you know, if you do a studio, we make you draw by hand for the first couple of studios, and I actually think that's still a very, very good idea. But and part of the reason that is, and I've been dealing with computers for actually since 1979, so it's not, I'm not a Luddite in that respect, but I still find that in terms of innovation and creativity and good design, starting right in with the computer tools is not a good approach. So I'm asking there's a whole bunch of issues wrapped up in what I'm asking is, what is it that's missing now in current software that we need to bring in order to make it more expressive and to keep that aspect of creativity? All right.
Yeah, I mean, I think there's quite a bit to see which way it goes, but one of the more, I guess, critical pieces would be to make sure everybody stays involved in sort of the discussions and any kind of industry events and stuff like that as things progress, because I think that is going to be a key, as well as making sure that opinions from all over the industry are able to get channeled to, you know, different industry voices. And then one of my fears right now is, are these behemoth software companies going to gain too much of an edge? So if you look at, you know, traditional tech, people are worried about Facebook and Google, but what about AEC? We have Autodesk and Trimble. Is that not going to pose a little bit of a threat as well? They are going to own almost all of the means of creating a lot of these buildings and operating them and all that kind of stuff. And so, yeah, it's very hard for me to give an answer that way, but I think increasingly we're going to be going back to more of, ironically enough, that traditional meaning of to be an architect, right? Somebody that can step back and interface with the broader building and understand certain elements of engineering and design and, you know, construction and so on and so forth, because maybe technology is going to take away some of those specialized tasks that we started to see that fragmentation was really helping with, right? So I think things like having technologists or junior architects working on blocks and bathroom tiles and stuff like that might get reduced, and we might start using more of these junior architects to start leveraging the technology to execute more on that operational side of things. But again, I'm just spitballing here, Douglas.
That's okay. That's what I was hoping for. We could almost talk all night about this issue alone. I will share with you, there was a fascinating discussion unfolding in the online magazine DZine, where they had a panel session where Patrick Schumacher, who has pretty much taken over Zaha Hadid's firm, was kind of trying to defend the whole concept of architectural interns basically working for free. And he was sort of claiming that this was, you know, part of the rite of passage. But he also then expanded that he thought that basically our architectural curriculum was out of date and had nothing really to do with the real world of construction. And he was pushing for a much more parametric approach to design. And it was fascinating on both dimensions of both labor and approach. It's a fascinating discussion. One we obviously won't solve very quickly, but it does have implications for what people do when they're working for an architect, and particularly if you're a junior architect.
Absolutely. I think that's a very big key right now, is from a lot of my friends and people, you know, I was in school with, those that are junior architects now and are back in the industry. And some of them are really struggling with that, quite frankly. And anybody that has the chance to work for an architect, it really isn't really, it's not a smooth sailing ship Let's just put it that way. But again, the competition is fierce, right? So, and again, we could dig too much into this topic, like Zaha Hadid alone, and sort of the inspiration of that architecture, I think, and how to build that. That could be a session of its own, right? So,
absolutely. In fact, to the best of my knowledge, and this is where it becomes very interesting, what Zaha Hadid's firm got into was a piece of software. I believe that they were using Maya originally. Maya was actually Canadian software created by a company named Alias out of Toronto, and it was used largely for a lot of the movies that you see, including way back with Jurassic Park. Eventually, they were purchased by Autodesk, and so Maya is still a product today, but it does have the capabilities of doing those wonderful curves that you see in Zaha Hadid's building. But it's a fascinating issue to think that beauty of those parametric models is tied to a pretty archaic approach to the use of labor. And I'm simply sharing that with you because it is so interesting and different. But I did have one other question, Hammad, and I do apologize for bugging you about this. But when you showed us the presentation when Henry and I were at your office, you talked about, I think it was Brookfield Place and your work with Dialogue, and how in terms of construction documents, and this is worth explaining in detail, that the architects hadn't provided much more than a really kind of brief sketch almost of some of the top elements of that building. And then you guys took it and articulated it. Could you expand on that just a little bit? Because that's a very different way of doing things in terms of building detailing.
Yeah, so what it was Dialogue did, produce the design with FKA or AFK at the time is what that other firm was. And they added their, construction contract document level of detailing. And they worked with Intuitive to get that structural level going. But we were able to work with the subcontractors to get it to a level where we were using, fabrication clearances and prefabrication approaches on this kind of stuff. So I'll actually pull it up on the screen because I think I have it open on my tab here. But what that meant is instead of having us to physically make mock-ups and go through a lot of the design reviews that you would see on typical projects, we were able to use the model and our construction team to really go through that.
But if you're showing the model, you'll need to unshare your screen and share the window because we don't see your model.
Do you still see my thanks screen?
Yeah.
Yeah, okay. So, do you see this screen now?
Yeah, we see a different PowerPoint coming.
All right, perfect. So we're good?
Yeah.
There you go. So here's some of the examples, right? So we were able to pull out that level of accuracy from the concrete. We were able to reroute entire systems, mechanical and structural, whereas with the design team, this could have been a very significant rework for them because we're using the trades and the fabrication. We know exactly where things need to go and minimize that impact. We're looking at where signage and wayfinding is located, right? So when's the last time anybody's heard of a project where we're using our 3D model to look at where signs are going to be compared to pipes and stuff like that? And this is one of those areas that I think you were talking about, Douglas, is the pavilion gutter, where it's a really cool butterfly roof. And, you can really see the design intent here, and they've shown some of the systems, but when it comes to the actual detail of how do you actually make this happen, that's where 3D modeling, working with our subtrades and contractors, came into use. And the same thing at the crown. So they had their parametric model with some of the, engineering requirements, but we got it to a level where we knew every nut and bolt and the different types of sort of forces on each of those, and working with the actual glass that was going to be in there and the different clips, and that sort of granularity, if you will, which led to the prefabrication. So yeah, any other questions about that project?
If I could just add, just so that for Jess and David, typically how that process would have occurred would be the architect would have produced that drawing in the drawing package, the one on everybody's left, and then it would have gone back and forth with requests for information and shop drawings and back and forth, and it takes an incredible amount of time as everybody tries to figure out exactly what that drawing really means when it's put into 3 dimensions. If I understood correctly, and it's a long, it's timely, and it's an expensive process. If I understand correctly from what Hammad said, they sort of moved beyond, or they almost ignored that process to go directly to start working out the details of it with the subcontractors, and then sharing what was essentially almost like what the as-built would be like. And so almost circumventing the entire requests for information, change orders, and all of that process to save time and money, but it's different, right? It's
exactly right.
It's a different approach.
Yeah, it's using more of like that manufacturing and sort of efficiencies that you would see in, you know, the airplane manufacturing, or, you know, mass production of cars and your cell phones and laptops, in a construction environment for architecture, essentially. So I'm not going to say that we eliminated RFIs and all that kind of stuff, but we definitely were able to pinpoint and work on collaborative sessions where we ironed out a lot of the issues. And any of the documentation we did have to send through was very purposeful and strategic, and it really added to that net benefit.
And may I just ask, and could you share with everybody, clearly you know a lot about this stuff, and you were an architectural technologist at SAIT, is that right?
Yeah, so I did my AT designation or program at SAIT. And at the University of Calgary, I did urban studies as well. So I worked for a couple of years as an architectural technologist for an architectural practice in Calgary. And then I worked for EllisDon as a project coordinator, as a BIM coordinator, and then, you know, worked my way more into the VDC and BIM side of things, and got to where I am today.
Well, it's very impressive. Thank you very much.
Thank you. And yeah, thanks everyone for calling in and your questions so far. If you folks have any questions or you want to reach out to me in the future, don't hesitate. Feel free to get my contact information from Douglas or from Henry. And again, Douglas, Henry, thank you guys for this opportunity.
I do hope that this is going to be the first of many of these, and I hope that people will spread the word. And of course, everybody is invited to attend as well. You don't just have to be in the Center for Architecture. But Henry, did you want to say, have some wrap-up remarks?
Yeah, I just wanted to thank Hammad again for your presentation and taking the time to speak to our students. We do have one more presentation next week, scheduled before Christmas. Our student, Brendan, who recently got accepted to the University of Calgary in architecture, will be talking to us about portfolio, designing a portfolio and putting a portfolio together for his admission to the university. And so if anyone would be interested in listening to his experience in going through the admission process at the U of C, next week, Tuesday, again at next time it will be at 7 o'clock Mountain Time. So spread the word. Hopefully we'll be able to do this again and organize more interesting speakers for us for you guys next, I guess next year.
Yes, and let me just put in a plug. I was told that Brendan's portfolio was a very strong contender. So it was considered to be a very strong portfolio. So if you are at all interested in getting into a master's program somewhere in the world, I would highly recommend Brendan's lecture, because if he's going to show you what he did, and it actually is a very handsome portfolio, and it's well worth seeing, because that's the caliber of work you've got to aspire to in order to get into some of these programs. So please, I think we should shake the, we'll we'll be shaking the tree to make sure everybody knows about this, because it's a very important lecture, as was tonight's, because it's, the first step is getting into a architecture school, but wow, when you're out on the job, what Hammad has shown us tonight is actually revolutionary. The construction industry, is kind of a little bit backward. In fact, some people would say it never even got into the industrial revolution. We're still building buildings much the way as they did when they were doing Gothic cathedrals, which is kind of a very interesting fact. But at the same time, from what we've just discussed tonight, it almost seems as if architects may evolve back into something like a master builder. The master builder on a Gothic cathedral wasn't in charge of every single detail because they had such skilled craftspeople who could do the different parts and pieces themselves. So often it was dependent on the quality of the workman as well, and the master just sort of coordinated these things coming together. So it's very exciting to think about how this might change, but it's also a little scary too, which is why we absolutely need to talk about these things in detail. So again, thank you, Hammad, for sharing these thoughts with us tonight. I really appreciate it. I actually learned it quite a bit. And thank you, Henry, for putting all of this together. And thank you to everybody who attended.
Thank you, and have a good night.
Yeah, thank you very much. Good night.
Take care, everybody.
Thank
Bye-bye.
you.
Bye-bye. Thanks, Henry. Thanks, Hammad.
Yeah, thanks.